The role of agroforestry in adaptation and mitigation to climate change. I'll be happy to share some concepts, some ideas, some evidence. And like any story in Java, we should start with the Gunungan, the story of the tree of life, the harmony between people, all the animals, etc. And then it flips around and we have the demons and we have the trouble happening with us. That's the climate change story. And what can we do? Mitigate or adapt? Well, one view, and I would call that the non-agroforestry perspective, is currently quite popular under the name half-earth discussion, claiming yes, let's keep half the earth for nature and all the animals and everything else, and that can mitigate for our climate change, and the other half is for people and the cities and all the farms that we need for that. And hey, in order to protect nature we need a lot of money, and we can earn a lot of money from the carbon market with offsets that allow on the other side business as usual development to continue. So this is the non-agroforestry perspective. What do we have to offer as an alternative to that? Well, agroforestry started some 40 years ago, a little more than that, and it started against a non-agroforestry perspective in which we have agriculture here, forestry there, and a wall in between. It started with saying, hey, there are things that happen on the interface that are trees on farm, agroforestry technologies, and we can try to find out what these are at the plot and the farm level. Then after 10-20 years we realized that important things beyond that technology happen at the landscape scale, where there are interactions between the forest and the agriculture in the social sphere, interactions in the ecological sphere, and we need to look at that whole interface of agriculture and forestry as a social ecological system under change. Even that, what we call the second agroforestry concept, was not enough, and we realized that the problem is to some extent in the policy domain, where agriculture and forestry have separate policy spheres, separate ministries, separate mandates, separate technical training at university, and the only sensible way is to look at them together. So our agroforestry 3 concept is the sum total of agriculture and forestry and anything in between, because we don't want to draw lines, because we don't want to create boundaries. As a research topic, we started the 1970s with a non-agroforestry separation. We moved into local technology, inventory of all the agroforestry forms. We went back to a more detailed research phase of understanding the processes, and then we gradually got more and more interested in the development side, and through that we got more and more involved in the policy matters. So our multifunctional landscapes in which agriculture, forestry, agroforestry all coexist does play a role in many of the current world's problems, including the climate and the environmental policy domain. But even within that we have seen separate measures for REDD, for the forest, from the discussion in agriculture that has been slower to start on the mitigation side. Well, the idea that agroforestry links adaptation and mitigation is not a particularly new one. We published about that some 15 years ago. We did a book on how trees and people can co-adapt to climate change, and we had empirical work in Vietnam and East African sites as well as in the adaptation. Is best understood as the reducing of risk, which means the reducing of 3 things: exposure, vulnerability, and hazards. Now, risk occurs when all these 3 come together. So when there is a hazard, there is a storm, there is a flood, there is a landslide, whatever, and people are exposed to it, they are in the wrong place at the time that it happens, and they are vulnerable. So adaptation can mean reducing exposure, it can mean reducing vulnerability, while mitigation is mostly about the reducing of the hazards. And Okay, but transformative change can happen when both are addressed at the same time. Now in this talk I'll touch on 7 different aspects of that. And the 7 aspects are different scales. So a number of them are at the scale of trees and how trees interact with soil and how agroforestry systems deal with that. Then we get a couple of points that are essentially at the landscape scale about floods and landslide risk, which lead to a concept of optimal tree density at the landscape scale. And then we go to maintaining landscape diversity, de-risking by options, an option portfolio, and finally the point that climate has an active role of vegetation in terms of the rainfall, recycling and downwind effects. So scale itself is a very important concept in everything around agroforestry, at the same time in everything around adaptation. And we can see that scale coming back in the way we analyze. If we start with the system state, the state of land as we find it, we can move upstream towards the pressure. Why are people doing what they do? And behind the pressure are the drivers, the demography, the policy frame that constrains and that stimulates farmers to do certain things. Or we can go from system state downstream towards the impact. What is the impact of the land cover change that we've seen? And then move to responses. Now responses in the dips here is sort of the end point, but it's more useful to see it as a loop. The responses can consist of, well, we can change. Adaptation is accepting that the system state is what it is, but reducing the negative impact. Mitigation is trying to shift the pressures and not affect the system state as much. Transformative change is dealing with the drivers, and the more holistic perspective is the reimaginative change. How can we shift the perspective of what does people need to be happy and healthy? Now, within that policy part, the loop, the responses part, we see 5 roles. There's the ABCDE, the agenda setting, a better understanding, coalitions, commitments, devolved implementation and evaluation. And adaptation in the climate change debate came relatively late. For a long period of time, the debate was mitigation should do the job. We should control, prevent climate change from reaching dangerous levels. By now, we've seen that has not worked, and we have to adapt whether we like. In the development world, there is a lot of different words, and whether we call it coping or resilience or adaptation, restoration, intensification, mitigation, transformation, sustainable development, in the end it's all about the same set of goals. It is all about removing all the different bottlenecks to development. And we can, if these 17 SDGs is too much to remember, we can go back to the triangle. It is about economic infrastructure, it is about social infrastructure, it is about ecological infrastructure. And when we make the list of what agroforestry can and cannot do, we see that it actually can be part of many different debates. It is about food, it is about energy, it is about water, it is about gender, it is about education, and also the ecological infrastructure, about the life on land, the life in water, and dealing with the climate change issue. A further concept that is relevant in this part is what we call the donut model. On one hand, we have planetary boundaries, make a list of all the things that can go wrong when we have too many people on the earth and while we're on this side of the sheet. And we do that because of climate change, because of extracting too much water, because of polluting with nitrogen, with phosphorus, the ozone layer. So that's, at the same time, this side of the donut is that we haven't achieved that happy, healthy life for a majority of people on the earth yet. So we have deficits in terms of food, health, water, energy infrastructure, and the development space is there. Now, the optimistic perspective of this diagram is that there is a safe operating space for humanity, that it is possible to achieve reasonable standards of living for everybody without trespassing the planetary boundaries. And okay, climate adaptation is part of that attempt to get back to that safe place. Well, at the highest level, we can see that it is a simple matter of what is the size of the planet and what is its resilience. And on the other side, how many people do we have? How much well-being per person do we want? How much consumption is needed per unit well-being? How much production do we need in order to meet the consumption? And then how much area do we need to generate that production, and what is left for nature after we meet all of that? Now, this level suggests that there are multiple intervention points. It is a question of what is that well-being that is desirable? What lifestyle choices do we have for quality of life? Reducing consumption and still achieving well-being? How can we reduce waste and have less production per unit consumption? And how can we reduce the negative impact on production on what we see? Yeah? So the Anthropocene equation at the highest level frames what adaptation can be like and what type of interventions in our land use, land cover system would help to bring us back to that operating space. Now, starting on the other side, we can see that we can start agroforestry at the scale of the tree, at the scale of the plot level. And then we see that, yes, planting a tree modifies the microclimate. People have done that around their houses, in their cropped fields, and benefit from the direct change of climate at the scale of where people live and where their crops grow. It can play a role in interacting with the soil, in increasing soil buffering, and adopting a multi-strata agroforestry perspective integrates that into a concept of agriculture. Examples. Within that, of course, the question always is which trees, what tree where, what is the right tree of place, and of course agroforestry is not uniform. We have very different climatic zones. We have what we call a tree cover transition. We start with natural forest, it gets logged, it gets degraded, it can be modified to become an agroforest, can get an open field agricultural situation, degraded lands, trees coming back in, and different parts of these trees we can call agroforestry and not. And at the same time we have a topographic dimension between the mountain slopes to the coastal zone, and different types of agroforestry are relevant in different ecological niches along that topography. So we have to be very careful that we can't take one observation of agroforestry at one point and claim that it is good everywhere. Each of these things, each of these contexts needs its own analysis and its own problem. Now, in terms of water, of course, we get this concept of buffering. Both too much water and too little is problematic for people. At the same time, rainfall is unpredictable and erratic. So to what degree can the trees, and influenced by the soil, buffer that flow and avoid both the too much and the too little, while rainfall itself is uncertain? For some analysis we did, we compiled data from many different plots that vary from tree cover, from very high tree cover in closed forest to very low tree cover in land that is managed by forest authorities, either natural forest or plantation, in land that is managed by farmers, and in land that is in the suburban domain. And of course, there can be trees everywhere, but they can be different trees and they have different roles. In one paper published this year, we looked at data on the soil in terms of the above ground biomass. Well, that varies from almost 300 ton of C per hectare in the natural forest to only 1 in the degraded imperata lands and things in between. At the same time, we had litter layer data as well, as data is uncertain. Now, for some analysis we did, we compiled data from many different plots that vary from tree cover, from very high tree cover in closed forest to very low tree cover in land that is managed by forest authorities, either natural forest or plantation, a land that is managed by farmers and a land that is in the suburban domain. And of course, there can be trees everywhere, but they can be different trees and they have different roles. All got included in the sample. So we have to be careful that the IPCC carbon stock change for going from forest to agroforestry to agriculture can be underestimated what is really happening. Now, a second paper I'd like to call on is just published based on work on cocoa agroforestry in Sulawesi, where we see there is ecological structure, function, services, benefits, value, but we have the structure of the above ground and below ground vegetation that interacts with the carbon cycle and that interacts with the water cycle. At the level of services, we have the productivity, we have the terrestrial carbon storage, and we have the buffering erratic rainfall. And one of them is specifically relevant at the policy scale. The other two are mostly relevant at the farmer scale. And the question is there synergy between that? For this analysis, the researcher, we looked at remaining forest, we looked at multi-strata agroforestry, 45 years old, 17, 10, 4-year-old cocoa mixed with trees, and this is the land clear. And we found in the data that across that data, yes, higher soil carbon is positively related with more macro porosity, with a lower bulk density, with higher saturated hydraulic conductivity, and the available water capacity increases by about 50 millimeter. Well, that's about 14 days at 3 millimeter per day. So it is helpful in bridging dry periods during the rainy season, but it doesn't carry you across the whole the dry season. In some further work, we looked at bringing in the roots into that story. This is a paper that should come out soon. And we get a closer look at how the choice of trees and the tree root system interacts with that matter of soil carbon and bulk density and the nutrition, and basically helps understand that yes, the multi-strata agroforest is more buffered than the monoculture, the sun cocoa, but it is still very far from forest conditions. Well, that brings us to the next point. To what extent is that plot level interaction between the trees, the roots, the soil and the water, does it lead back at landscape scale to managing a number of the risks, reducing the exposure, reducing the vulnerability of people? And within that, we have, first of all, the point of the flood and the flood risk and buffering. And then we see actually that in many of these issues around disasters, we can start with the symptoms, we can start with the land cover as it is, and we see, hey, there are floods, there are fires, there is drought, there is loss of soil, there is pollution of the lake, there is washed out bridges, there is no water in the tap, the hydropower doesn't function. Many things are symptoms, are problems of global climate change. But when you go to the branches of the tree, you can say, well, many of them come back to loss of hydroecological buffering, and that is the consequence of land use choices being made, and often is the source of conflict. If you want to solve the problem at the roots, we need to know the roles, who is doing what are the drivers, what are the rules, and that's an analysis that often sees that these different symptoms come together in terms of what can be done and should be done about it. Now, some recent work in Rejoso in East Java, we looked at how much does it matter, how much canopy cover there is in terms of trees, going from almost closed canopy to nearly open. And we see that yes, it matters for the part of rain that gets intercepted and evaporated from that, but the relation is different from the upstream, from the midstream zone, because of different canopies and different rainfall patterns. At the same time, we see that overland flow is a dramatic source of erosion in the undesols in the upper part, whereas in the middle zone we can have almost as much runoff as you want and still have very little erosion because the soil has a very low entrainment factor. So the people who say we need 30% forest in order to protect watershed functions, well, that's a random choice within something where it matters very much where you are, what of trees they are and what soil. A further point towards the role of trees in adapting and reducing landslide risk is in the type of root system that we have. We just published a paper on summarizing this work on tree roots, anchoring and binding soil. And if you put it simple, separate the trees in the normal trees that look like every other tree, and there are trees that are in 4 ways are different. There are trees that have relatively few roots, where the ratio of root cross-sectional area and stem cross-sectional area is quite low. We have trees with a lot of roots relative to the stem. We have, on the other side, trees where most of the roots are horizontal, and we have trees where most of the roots are vertical. Now, clearly, in terms of landslide protection, we need 2 functions. We need the anchoring, we need the vegetation as a whole need to be pinned into the subsoil, so we need vertical roots. At the same time, we need horizontal roots to keep things together. So, knowing what type of tree has what root system at what place can help us make a bit more informed choices of that. At the same time, the simplest rule is that diversity of trees is almost always a good thing to have. It almost always means that you'll have some trees with deep roots, some trees with shallow roots, and you'll be better off than choosing any single type of tree where they are. Understanding adaptation. A very important part is indeed understanding water and understanding all the different things that can go wrong when buffered systems are replaced by unbuffered systems and when water starts flowing through the landscape, rapidly causing floods when it rains and not being enough buffered and not providing enough water in the dry season. So climate change adaptation brings us back in a big way to the whole debate about watershed management, which has been a strong drive to combine forest and agriculture, to have trees scattered in the landscape for these roles. At the same time, to see that it is not the total amount of trees that matters as much of where they are and are they at strategic places protecting the functions where it is most needed. And in that sense, the climate change adaptation debate should bring us back to all the ideas about integrated water. Within that, we can say, well, we can try to understand the water balance, what comes in terms of rainfall, what does vegetation and tree do in terms of interception, in terms of evapotranspiration, and how does it partition water between overland flow and base flow. So that's understanding at the process level, and with the more recent insight that it is not a flow but a cycle, that rainfall recycling over continents actually is an important part, and maybe even half the rain over continents is recycled. At the same time, we can look at it from a human lens of function. So what is we have here 9 watershed functions, the water transmission, the annual yield, the buffering, the infiltration, etc. We can try to understand what do trees do where in terms of supporting these functions, and would it make sense to say at the landscape scale that for climate adaptation we want to get more trees in order to reduce vulnerability and exposure. Well, that comes then to this point of de-risking by option, having multiple things happening. And we've seen, for example, in the COVID exposure, that farming systems with multiple options, farmers found something else to do when some of the markets collapsed and others were growing, whereas highly specialized farmers were into much more trouble. And that brings us to that last point of managing the rainfall recycling, which for an island archipelago like Indonesia is not as important as it is for Africa or Latin America. But there is increasing evidence that over the island of Borneo, rainfall recycling does play a significant role, mostly because the wind speeds are so low that moisture does stay over Kalimantan long enough to rain back. Which brings me to a final point, that classification that we have for climate change as either mitigation or adaptation is a bit like thinking that there are only 2 sides to a coin. And if you have a real coin, you'll see that it has a third. side. Yeah, and so the way we looked at mitigation as reducing the greenhouse gas emissions so that the atmosphere would not change so fast and the climate systems could function. Adaptation is dealing with the consequences of climate change. Well, in between, we see the third side of the coin is that tree cover and forest and agroforestry can have a direct effect on the climate system through, for example, rainfall recycling beyond moisture content, winds and temperature. And I think it's only gradually that we start to understand it. Unfortunately, the climate policy debate has focused on this mitigation and adaptation as two parts. So modifying rainfall by vegetation does not have a clear niche within the policy agenda as it has been framed, and it often comes in under the adaptation, but actually it is not just adaptation, it is actually modifying the climate as well. That debate I started off with, that half-earth part, and all the debates about agroforestry actually have, you can say, two dimensions. One is how much forest and tree cover do we have, do we want, do we need, and then how is it distributed? If you think of human needs in terms of urban areas, transport, industrial areas, open field agriculture, half open agroforestry, natural forest and its analogues, we can go on the left side and see very fine-grained mosaics, where the whole mosaic might be called agroforestry. We shift to the right and we get coarser and coarser patterns. We remove all the trees from the agricultural landscapes and we end up on the right-hand side with very strongly segregated land use planning, where we have the cities as cities and the agriculture as agriculture and the natural forest and the agroforestry for the half-open systems. So what is better, fine-grained or coarse? For what function and how? That is in a way the ultimate question. Now we can see that in terms of the Sustainable Development Goals, the answer can be anything you want. For some functions, the closer sharing, the closer mosaic is more functional. For others, it is the segregation. We see the Global Deal for Nature that wants a strong segregation. That's an extreme form of the land sparing. Have half for nature and the other half people can do whatever they want. Now, we see the current debate on the experience with the coronavirus. We see two opposite trends. On one hand, we see that the lockdown has shown that the multifunctional integrated systems were more lockdown proof, where people had less negative impacts there. On the other hand, there's an argument from a hygienic perspective, to separate animals from people for the future, to avoid any next zoonosis to jump over to people. And the debate will continue. So which of those functions, how can we reconcile? More trees, more forest, less trees, more space for people, finer grained mosaic. And I think our debate on what is adaptation to climate change ultimately would come down to these large questions. At the same time, we have to build up the argument from knowing the trees, understanding the soil, and seeing how they interact. I look forward to discussing this. Thank you.